Find the efficiency of a cycle consisting of two isochoric and two adiabatic lines if the volume of the ideal gas change n equals to 10 times within the cycle. The working substance is nitrogen. According to the question, the cycle consists of two isochoric and two adiabatic lines. The graph is drawn as shown. Process 1 to 2 is adiabatic compression. Process 2 to 3 isochoric heat addition. Process 3 to 4 adiabatic expansion, and process 4 to 1 is isochoric heat rejection. Now we know the efficiency is defined as eta equals to net work done divided by net heat added. Now, since the work is done only during the adiabatic expansion and compression, for constant volume process, the work done will be 0, and hence the first law thermodynamics dq equals to d. Hence, heat added during process 2 to 3 dq 2 3 equals to Cv T3 minus T1 for 1 mole. Similarly, heat rejected in the process dq 4 to 1 equals to Cv into T4 minus T1 for 1 mole. Hence, the work done dW equals to heat added minus heat rejected equals to Cv T3 minus T2 minus Cv T4 minus T1. Now efficiency eta equals to net work done divided by net heat added, Cv into under bracket T3 minus T2 minus Cv into under bracket T4 minus T1 divided by Cv into T3 minus T2. Hence, now from 1 and 2, eta equals to 1 minus T4 minus T1 divided by T3 minus T2, equation 3. But during adiabatic process 1 to 2, T2 equals to T1 under bracket V1 by V2 to the power gamma minus 1, and T3 equals to P3 T2 by P2 in process 2 to 3. Also, T4 equals to T3 into under bracket V2 by V1 to the power gamma minus 1. Putting all the values of T2, T3 and T4 in equation 3, we get eta equals to 1 minus 1 by n to the power gamma minus 1 equals to 1 minus n to the power 1 minus gamma. Hence, V1 by V2 equals to 1. This cycle is known as Otto cycle, on which all the Otto vehicle runs. Find the efficiency of a cycle consisting of two isobaric and two adiabatic lines if the pressure changes n times within the cycles. The working substance is an ideal gas whose adiabatic exponent is equal to gamma. The solution. The situation of the problem is shown in the figure. Here, process 1 to 2 is adiabatic compression, process 2 to 3 is heat addition at constant pressure, and process 3 to 4 is adiabatic expansion, and process 4 to 1 is heat rejection at constant pressure. Now, we have heat addition QA equals to Cp T3 minus T2 for 1 mole of gas, and similarly heat rejection QR equals to Cp T4 minus T1 for 1 mole of gas, and work done will be equal to QA minus QR. The Cp into under bracket T3 minus T2 minus of Cp into under bracket T4 minus T1. Hence, efficiency eta equals to work done by heat added equals to Cp into under bracket T3 minus T2 minus of Cp into under bracket T4 minus T1 divided by Cp into under bracket T3 minus T2 equals to 1 minus under bracket T4 minus T1 divided by under bracket 3 minus T2 equation 2. Now for adiabatic process 1 to 2, we have P1 V to the power gamma, P1 V1 to the power gamma equals to P2 V to the power gamma. This implies P1 into under bracket RT1 by P1 to the power gamma equals to P2 into RC2 by P2 to the power gamma. This implies T1 to the power gamma into P1 to the power 1 minus gamma equals to T to the power gamma into P2 to the power 1 minus gamma. Hence we get T2 by T1 under bracket P1 by P2 to the power 1 minus gamma by gamma. And during process 2 to 3, V3 by T3 equals to V2 by T2, since P1 equals to P3. Hence T3 equals to V3 by V2 into T2. During process 3 to 4, T4 by T3 equals to P4 by P3 to the power 1 minus gamma by gamma. Hence T4 equals to T3 into under bracket P4 by P3 to the power 1 minus gamma by gamma. From equation 2, 3 and 4, putting the values of 2, T3, T4, we get eta equals to 1 minus n to the power minus of under bracket 1 minus 1 by gamma, where n equals to P2 by P1 equals to P3 by P4. An ideal gas whose adiabatic exponent equals n goes through a cycle consisting of 2 isochoric and 2 isobaric lines. Find the efficiency of such a cycle if the absolute temperature of the gas rises n times both in the isochoric heating and in the isobaric expansion. Solution in the graph shown. Process 1 to 2 is isochoric heating. Process 2-3 is isobaric expansion. Process 3-4 is isochoric cooling, and process 4-1 is isobaric compression. It is clear from the graph that the work done will be only during process 2 to 3 and 4 to 1. Hence total work done P2 into under bracket V3 minus V2 minus of P1 into V4 minus V1. Now heat is added during process 1 and 2, hence dq equals to Cv into T2 minus T1 for 1 mole. The efficiency of the cycle is given by eta equals to dW by dq equals to P2 V3 minus V2 minus of P1 into V4 minus V1 divided by Cv into T2 minus T1 equation 1. Now according to the question, T2 by T1 equals to n and T3 by T2 equals to n. Also P1 by T1 equals to P2 by T2. This implies P1 by P2 equals to T1 by T2. V3 by V2 equals to T3 by T2 equals to n. And V1 by V4 equals to T4 by T1. Equation 3. Putting these values and Cv equals to R by gamma minus 1. And from equation 1 and 2, using these all values, we get the efficiency eta equals to 1 minus under bracket n plus gamma by 1 plus gamma n. Answer.